and welcome to Module 6. My name is Dr. Priyan Arumugam Nanulal. I'm a senior research scientist at the WASH R&D Center at the University of KwaZulu-Natal in Durban, South Africa. Our group has worked extensively with the Bill and Melinda Gates Foundation on the Reinvented Toilet Challenge, and specifically on the ISO 3500 standard and testing of new technologies. As a pre-reading, you were directed to the ANSI website to download the ISO 3500 standard to give you a full understanding of its contents. ISO 3500 was published in October 2018 and specifies the general safety and performance requirements for the design and testing, as well as the sustainability considerations for non-sewage sanitation systems. The standard was developed by experts from 32 participating countries and 16 observing countries who served as members. Since then, it has already been adopted by 13 countries, 8 of which are from Africa. The second country in Africa to adopt it identically was South Africa. Revisiting the sanitation value chain, non-sewage sanitation systems are designed to contain, treat, and allow for the safe reuse and disposal of the treated outputs on-site. That is, none of the fecal material is transported off-site for treatment like other on-site sanitation technologies such as pit latrines. By definition, a non-sewage sanitation system is a prefabricated integrated treatment unit which can have a front end, which is the toilet facility, but must have a back end, which is the treatment facility. A non-sewage sanitation system collects, conveys, and fully treats the specific input within the system to allow for the safe reuse or disposal of the generated solid, liquid, and gaseous output. The term non-sewage specifies that the system is not connected to a network sewer or a network drainage system. We will now look through the components of a non-sewage sanitation system. These are some examples of front ends, which are essentially what the user interface is. Some examples include urinals, squatting pans, or sitting pans. Some manufacturers will design their systems with their own specific front ends, or it can be designed to be integrated with any front end currently in the market. The type of front end is at the manufacturer's discretion, as it is generally specified in the user manual. In terms of the evacuation mechanisms, some front ends will have a conventional flush or pour flush, while some will be dry toilets. More novel evacuation mechanisms have been developed which employ mechanical forces with little to no water, like the technology on the right. Please visit the ANSI website on the link below for more information on these technologies. Another possible design feature on the front end is the combination with urine diversion. Urine diversion can be applied to flushing toilets as well as dry toilets. Some of these applications have been illustrated here, designed differently for various mechanisms of anal cleansing, such as wipers, those who use toilet paper, and washers, those who use water. Moving on to the back end, which is the treatment facility. As mentioned previously, a non-sewage sanitation system has to have a back end. Those with front ends only are not considered a non-sewage sanitation system. The treatment processes in the back end can range from biological processes such as anaerobic or aerobic digestion to chemical processes such as combustion or electrochemical disinfection, to physical processes such as the use of membranes. Some technologies will use only one treatment process, while others will use a combination of processes by integrating several treatment units. An example of this is the anaerobic digestion, followed by electrochemical disinfection. This is an example of a reinvented toilet funded by the Bill and Melinda Gates Foundation during the Reinvented Toilet Challenge. The hydrothermal carbonization unit has a vacuum flush toilet that uses under a liter of water for flushing. The back end uses high temperature and high pressure processing, where the final products are energy converted into electricity, clean water for reuse in flushing, and fertilizer. For more information, please visit the ANSI website on the link below. We will now move on to the classification of non-sewage sanitation systems. Ideally, a Class 1 and Class 2 system are for single households, while Class 3 systems are multi-user systems, ideally for school sanitation as well as community settings. This is a Class 1 system in a dry combustion technology, where the front end is a waterless toilet with a swiping flush mechanism. In the back end, solids are extracted by a specifically designed screw, then dried and combusted, while liquids are preheated and purified with a hydrophobic membrane. This is another Class 1 system, the hydrothermal carbonization unit. Here, a vacuum flush pedestal is connected to a back end that uses high temperature and high pressure to treat the liquid and the solid fractions. I will now show you examples of Class 2 and Class 3 systems. The Class 2 new generator is a compact, portable, and modular resource recovery machine that eliminates waste while recovering fertilizer, nutrients, renewable energy, and clean water. The system uses an anaerobic membrane bioreactor that processes the solid and liquid fraction in a single dilute waste stream. Minerals and nutrients are removed from the wastewater by a hydroponic bioabsorption system where the biogas from waste product digestion is collected for use outside of the system, such as that used for cooking or heating. This is an example of a Class 3 system. The EcoSun is one of the leading developers of the Caltech technology, focusing on school and public toilets and containerized toilet units. The system can be combined with any type of flushing front end. Back-end processing technology capitalizes on the anaerobic digestion of solids and an electrolysis system to convert waste into water, hydrogen, and solid fertilizer. The design can be fully containerized or with a separate digestion tank. Patented electrochemical cells process mixed wastewater. The liquid output can be recycled as flushing water. This is an example of a Class 2 non-sewage sanitation technology upscaled to a Class 3 system. The new generator scalable system is an example of this, upscaled from a single household capacity that is for up to 10 users to more than 1,000 users per day. In the design presented on this slide, the capacity is up to 300 users per day, or roughly 60 users. It is a multi-unit system which is appropriate for community toilets, schools, and multi-unit dwellings. For each of these classes, one can refer to the ISO 3500 standard to design towards a safe and quality product for the market. In this slide, we present an overview of the design, performance, and safety testing of a non-sewage sanitation system undergoing certification against ISO 3500. Please refer to the standard document for more detailed information on the clauses and test methods. Going on to the certification process, this includes 3 phases. The first is the document checks, whereby the manufacturer will submit all of the design documents, verification certificates, and the user manual to the certification body for evaluation. This is then followed by controlled laboratory testing, which is no less than 32 days, depending on the actual type of technology. During the controlled laboratory testing phase, all outputs are evaluated. These include measuring the stipulated environmental parameters of the liquid output, the human health parameters of the liquid and solid outputs, indoor and outdoor air emissions, and the odor and noise produced during operation. If the system passes all of the criteria dictated by the standard, then field verification of performance is done. In this phase, only the environmental and human health parameters are evaluated from the liquid and solid outputs. For the different classes of non-sewage sanitation systems, the period of the field verification will differ. With Class 1 systems, that is those without a biological treatment process in the back end, being a shorter period since biological treatment processes take a longer time to start up. Once the system passes the field verification, a certificate is issued by the certification body. Now that you've been presented with all of the classes of non-sewage sanitation systems, we will now watch a video produced by TÜV in Singapore over the testing and certification processes.
TÜV was nominated as project leaders for Project Committee 305. After spending the last 3 years in validating the ISO 30500 with experts, we are now ready to move into the next phase of validating the standards. With our expertise as a certification and testing body, we have conducted testing with manufacturers on different types of sanitation technologies. The standard can be broken down into three main parts: document check, control lab testing, and field verification of performance. The first component to meet the certification of the standard is to comply with the required document checks. The second portion of the ISO 30500 is controlled lab testing. The lab testing involves a test sequence of minimum 32 days with a prescribed loading pattern. The aim of this segment is to ensure the reliability of the unit tested under a strict set of conditions. Last but not least, field testing is required to ensure that the system is robust in real-world conditions. The following segment shows a recent testing in Durban, South Africa.
For this round of field testing, we'll be doing a series of tests for human health and environmental parameters on the EcoSun eSync unit.
Depending on the type of system, these tests are to be carried out weekly over a course of up to 5 months. This validation work has given TÜVSÜD invaluable knowledge on testing out the new standard, and for manufacturers, an opportunity to test for certification readiness.
In this video, you were hopefully given a better understanding of non-sewage sanitation technologies, the ISO 3500 standard, and how you could develop different technologies to service the sanitation service chain. We also provided you with real examples of how South Africa has been used as a location to test out these parameters and the standard, and how commercial partners are preparing to meet these requirements by providing improved sanitation products. In so doing, we are demonstrating readiness for the new sanitation economy. You've now been introduced to the ISO 3500 standard, the different classes of non-sewage sanitation systems, and the certification process. We will now move on to developing a certification scheme, especially for those countries who have identically adopted the ISO 3500 standard. On this slide, we will present a generic overview of how one is to develop a certification scheme, or mark scheme. Once a mark has been developed by a certification body and the certification service is active, technology developers will then apply for certification for their market-ready and commercialized products. It must be noted that the entire cost of certification is that of the technology developer. After the application has been received by the certification body, the formulated technical assessment committee, which also consists of experts and consultants within the sector, will then devise a draft testing plan. This draft testing plan is reviewed by the technology developer. Each testing plan is specific to the technology being certified. Thus, based on the feedback from the technology developer, the Technical Assessment Committee would then finalize the testing plan and the inspection of the factory where the technology is being manufactured. Testing proceeds thereafter. After testing, the product specialist completes the evaluation report, which is sent to the technical committee for review. If successful, the board of the certification body will issue the certificate, which is usually valid for a stipulated period of time and is subject to annual review. Currently in South Africa, a certification mark scheme is currently being developed to allow for the commercialized non-sewage sanitation products to be certified against ISO 3500 or SANS 3500 as it is identically being adopted.